Imagine having the option to get a 3D printed organ. No more waiting on a list. Well, a team of biomedical engineers from Carnegie Mellon University are bringing us closer to that reality. Say hello to the first flexible, full-size 3D print of a human heart. This heart mimics the structure and elasticity of the real thing. The invention promises advances for the medical field, and future iterations could one day save someone's life. You've definitely seen this kind of printer before. This is a kind of additive manufacturing printer where each layer is supported by a sturdy layer below. Additive manufacturing printers are popular, but are typically known to build hard objects using materials like plastic or metal. But rigid plastic organs aren't very practical. These printers could be used with softer materials like biological hydrogels, to make a heart, but those tend to collapse mid-print. But this new method can change the game. The 3D printing technique is called Freeform Reversible Embedding of Suspended Hydrogels, or FRESH. It can print biological structures with soft, squishy materials like alginate, a biomaterial made from seaweed, which feels like human tissue. And it cleverly solves that collapsing problem during print by suspending flexible materials inside a container of gelatin. It's like hair gel, but with body parts in it. So how does it all work? Well, for this team of researchers, it all starts with an MRI scan from a real heart. The scan gets digitally chopped up into horizontal slices by a program which then translates them into code that a printer will understand. A needle-like nozzle moves through the gelatin support bath, extruding thin layers of alginate. The layers stack on top of each other to build the shape. When the print is complete, it's put in an incubator overnight where the temperature is raised to 37 degrees Celsius to gently melt away the gelatin support structure, leaving only the 3D printed heart. In this full-size test, they were able to reproduce features as thin as 2 sheets of paper, and in smaller scale tests, they managed to get them as fine as a human hair. 3D hearts have been printed before, but they've all been too small, more fit for a rabbit or a mouse than a human. Full-size 3D printed hearts can also be used as educational tools to help surgeons prepare for surgery. Older surgical models are made of rigid plastic or rubber, so they're helpful for planning, but limited because surgeons can't interact with them like real tissue. Fresh hearts can be cut and sewn up just like a real heart. Now surgeons can use these more realistic models to refine surgical techniques and test their tools in advance of the actual surgery. So their practice test isn't, well, you. And one of the coolest parts is that it could be a print of your specific heart. This will allow hospitals to personalize replacement tissues. For example, if you have a blocked artery and need a stent put in your real heart, the surgeon can test the stent with the 3D printed heart to make sure that it's a good fit. They're beginning to use this technology to help design functional parts that in the past have been hard to get right. Collagen-printed tri-leaflet heart valves are able to open and close, and printed coronary arteries help move blood around the body. Even ventricles made with cardiac muscle cells can visibly contract and start to synchronize. All of this is great, but it's not yet a functional beating heart. Scaling up from an artery to the real deal is no small matter. Using actual human tissues as bioink for an organ printer can be prohibitively expensive at the volumes needed. According to one source, a heart made out of alginate is around $10. The same heart made out of collagen, $2,000. But if you're on the waiting list for this essential organ, you might be willing to pay any price. Time is also a factor. Currently, a full-scale fresh model takes 4 days to complete. If we printed with living cells at that rate, many would die during the process. To make a full-size heart, you need billions of cells. Current technology can only produce a fraction of that, so there's still a long way to go. Even if a fully functional heart can't be created right now, the team at Carnegie Mellon is already hard at work refining the fresh technology so it can build more complex models. One day, these printed tissues could be used to test drugs more safely, decrease animal testing, and even replace or repair damaged organs with a new, healthy 3D printed duplicate. One thing we can count on for sure is that they're really putting their hearts into it. If you thought 3D printed hearts were cool, check out this video on how researchers are using light to print in 3D. If you have any cool tech that we really need to know about, let us know down in the comments. Make sure to subscribe to Seeker, and thank you so much for watching. I'll see you next time.